Good morning. Today we are going to start lesson number 2, that is Pythagoras Theorem. You have already learned about Pythagoras Theorem and also we have solved some examples of examples on Pythagoras Theorem. But in this lesson we will learn more about Pythagoras Theorem, we will see proof of Pythagoras Theorem and we will solve examples on it also. First we will revise definition of Pythagoras Theorem here again. In a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of remaining two sides. This definition you have already learned here, we will just revise here. See once again, in a right angle triangle, now here it is right angle triangle, that is triangle ABC, and right angle triangle means one angle of the triangle is right angle or measure of that angle is 90 degree. Now in this triangle ABC, measure of angle ABC is 90 degree or angle ABC is right angle. Now the square of the hypotenuse. Now what is hypotenuse in this triangle? And the hypotenuse is nothing but the side opposite to right angle or side opposite to 90 degree. Side opposite to right angle is always hypotenuse in right angle triangle. Now angle B is right angle, therefore side opposite to angle B is AC is nothing but hypotenuse. This is hypotenuse. Square of the hypotenuse is equal to, now square of hypotenuse means hypotenuse is AC, AC square is equal to sum, is equal to the sum means addition of the squares, sum of squares of remaining two sides. First side we have taken as AC, that is hypotenuse, and remaining two sides of this triangle are AB and BC. Means AC square is equal to sum of squares of remaining two sides means AB square plus BC square. This is about Pythagoras theorem or statement of Pythagoras theorem. See once again, for that triangle must be right angle triangle. Means in right angle triangle ABC, hypotenuse is AC and square of hypotenuse means AC square is equal to sum of squares of remaining two sides, that is AB square plus BC square. AC square is equal to AB square plus BC square. If I change names, then formula will also change. Suppose here is C, here is A and here is B. Then this formula will become CB square is equal to, hypotenuse will also change. Hypotenuse will be same but name is changed here. CB square is equal to CA square plus AB square. CA square plus AB square. This hypotenuse square is equal to sum of squares of remaining two sides. This is about statement of Pythagoras theorem, proof of Pythagoras theorem that we will see during next live session. Now in this live session we will learn about Pythagorean triplet and two theorems which we require to prove Pythagoras theorem, and we will solve some examples also of Pythagorean triplet. This is about Pythagoras theorem or definition of Pythagoras theorem. Now we will move towards Pythagorean triplet. I have already written definition of Pythagorean triplet. Triplet is nothing but group of three numbers or set of three numbers. Now in a triplet of natural numbers, means there are three natural numbers. Triplet means three or three natural numbers. We will consider three natural numbers. If the square of the largest number, means out of these three numbers, one number is largest number, square of that largest number is equal to the sum of the squares of the remaining two numbers. Square of the largest number is equal to sum of squares of remaining two numbers. Then that triplet is called Pythagorean triplet. For example, and considering one example to prove Pythagorean triplet or to explain Pythagorean triplet, suppose 9, 12 and 15, these are three numbers, or this is one triplet of natural numbers. These are natural numbers starting from 1 to up to infinity. 9, 12 and 15, these are three numbers, or this is triplet. We don't know it is Pythagorean triplet or not. We will prove it is Pythagorean triplet or not. Now these are the three numbers. Out of these three numbers, which one is largest number? Largest number is 15. Therefore take 15 square is equal to 225. Take sum of squares of remaining two numbers, that is 12 square plus 9 square plus 12 square, or we can also write 12 square plus 9 square. 9 square is 81, 12 square is 144, and that is equal to 225. Means 15 square is square of largest number is 225, and sum of squares of remaining two numbers is also 225. Means we can write 15 square is equal to 9 square plus 12 square. The square of largest number is equal to sum of squares of remaining two numbers. Therefore 9, 12 and 15. This is one of the Pythagorean triplet. This is Pythagorean triplet. Similarly, you can write other Pythagorean triplets also, like whereas 3, 4, 5 is there, then 5, 12, 13. These are the Pythagorean triplet that also you can write. It's about Pythagorean triplet. Now we'll move towards one shortcut to find Pythagorean triplet. Or formula to find Pythagorean triplet. Formula for Pythagorean triplet. Or formula to find Pythagorean triplet. If A, B, C are natural numbers, if A, B, C are natural numbers and A is greater than B and A is greater than B, then first number is A square plus B square, second number is A square minus B square, and third number is 2AB is a Pythagorean triplet. Means which satisfies Pythagoras theorem, Pythagorean triplet. See, A, B, C, these are the three natural numbers, and A is greater than A is greater than B, and then these three numbers, that is first number is A square plus B square, second number is A square minus B square, and third number is 2AB. These three numbers forms Pythagorean triplet. Now we'll check these three numbers forms Pythagorean triplet or not. For that we have to check square of the largest number is equal to sum of squares of remaining two numbers. Before that we'll find out squares of all three numbers, then we'll take sum. Now square of first number A square plus B square bracket square, square of second number, that is A square minus B square bracket square, and square of third number, that is 2AB bracket square. We'll find out squares of all these three numbers first. Now A square plus B square bracket square, we know formula for A plus B bracket square is equal to A square plus 2AB plus B square. The square of first term plus twice of product of these two terms and square of second term. Using this formula, but first term is A square, second term is B square, therefore A square square, that is A raised to 4, then twice of product is 2 into A square B square plus second term square, that is B square square, that is B raised to 4. Then A square minus B square, A minus B bracket square is equal to same formula, but this sign will change as minus, that is A square minus 2AB plus B square. Therefore we get A raised to 4, A square square means A raised to 4 minus 2A square B square plus B square square, that is B raised to 4, and 2AB square, that is 2 square is 4, A square is A square, B square is B square. These are the three squares of these three terms. Now take sum of squares of smaller two numbers, and I think these two are smaller. Therefore, taking sum of these two, I can write a square minus b square plus, means this plus this, 2ab square is equal to sum of squares of smaller two numbers is equal to this answer plus this answer. I am writing this as it is. It's a raised to 4 minus 2a square b square plus b raised to 4 plus 4a square b square. That is equal to a raised to 4 minus 2a square b square plus 4a square b square, means 4 minus 2. 4a square b square minus 2a square b square, that is 4 minus 2, that is 2. 2a square b square plus this term as it is, b raised to 4. And that is nothing but a raised to 4 plus 2a square b square plus b raised to 4 is equal to square of the largest number, that is first term, that is a square plus b square bracket square. Means we got here square of the largest number or square of one number is equal to sum of squares of remaining two numbers. Therefore, these three numbers forms Pythagorean triplet. Square of this number is equal to sum of squares of these two numbers. Therefore, these two numbers forms these three numbers forms Pythagorean triplet. Means by using this formula, we can find out various Pythagorean triplets. That we'll find out by putting values of a and b. A and b are natural numbers, and taking a is greater than b. That I'll solve here. If you want screenshot, then take it. Otherwise, it is in your textbook also. We'll prove this by using some examples. I'm putting some values of a and b. Let a is equal to 5 and b is equal to, a is greater than b, therefore b must be smaller than a. Suppose b is equal to 2, a is 5, b is 2, a is greater than b. Now the first term will become a square plus b square, that is 5 square plus 2 square, that is 25 plus 4 is 29. Second term is a square minus b square, that is 5 square minus 2 square, that is equal to 25 minus 4, that is 21. And third term is 2ab, that is 2 into 5 into 2, that is 20. 5 into 2, 10 into 2, 20. The first term or bigger number is 29, then remaining two numbers are 20 and 21. Now check, these three numbers form a Pythagorean triplet or not, that is 29, 21 and 20. Check these three numbers form Pythagorean triplet or not. We'll check. Square of bigger number, that is 29 square is 841. 21 square is 441. And 20 square is 400. Now take sum of squares of these two numbers, that is 441 plus 400, that is 841. Therefore, sum of squares of two numbers is equal to square of the largest number. Therefore, these three numbers forms Pythagorean triplet. We can write this Pythagorean triplet any or by using any order, like this also, or 21, 20, 29 also, or suppose 20, 21, 29. You can write in any order. Numbers will be same, but we can write by using any order. And these three numbers forms Pythagorean triplet by putting different values of a and b, but taking natural numbers, and condition should be a should be greater than b. We can find out various Pythagorean triplets. You can solve your own examples also by using this formula. If you want screenshot, then take it, and we'll move towards next part. That is property of 30, 60, 90 degree triangle. That also we have learned in last year. I'll just revise that property here again. That is property of 30, 60, 90 degree triangle. You have learned proof of that theorem also. I'm going to revise it again. Property of 30, 60, 90 degree triangle. Means there is a triangle containing or having angles as 30, 60 and 90. Obviously, suppose triangle ABC in which angle B is 90 degree. Suppose this angle is 30 degree and this one is 60 degree. Means in a triangle with angles as 30, 60 and 90 degree, and the statement tells us that side opposite to 30, I am going to write in short, side opposite to 30 degree is half of the hypotenuse and side opposite to 60 degrees side opposite to 60 degree is root 3 by 2 times the hypotenuse. This is statement of 30-60 degree 30-60-90 degree triangle theorem. If angles of a triangle are, or in a right angle triangle, the acute angles are 30 degree and 60 degree, then side opposite to 30 degree is half of the hypotenuse and side opposite to 60 degree is root 3 by 2 times hypotenuse. Now meaning of this statement is, given will be in triangle ABC, measure of angle A is 60 degree, measure of angle B is 90 degree, measure of angle C is 30 degree, means triangle ABC is 30-60-90 degree triangle. Then what is to prove? What is to prove here? That is side opposite to 30 degree. Side opposite to 30 degree is AB is half. Half means 1.2, half of hypotenuse, and hypotenuse is side opposite to 90 degree, that is AC. Means here meaning of this first part of the statement is side opposite to 30 degrees AB is half of hypotenuse, that is AC. This is first part. And second part tells us that side opposite to 60 degree, side opposite to 60 degree, that is BC, is root 3 by 2 times, that is root 3 by 2 into hypotenuse again, that is AC. This is meaning of this 30-60-90 degree triangle theorem that we have already learned during previous year, or you have seen proof of this theorem also. I'll just revise here again. Side opposite to 30 degree is half of hypotenuse and side opposite to 60 degree, that is BC, is root 3 by 2 times hypotenuse, that is root 3 by 2 times AC. Means meaning of this one is, suppose hypotenuse is, I'm going to solve one example by using this relation. Suppose hypotenuse is 8 centimeter, then by using this value we can find out AB and BC also. Since if it is a triangle 30-60-90, then only. Now since AC is 8, side opposite to 30 degree, that is AB will be equal to half of AC, that is half of 8, therefore 4. By using AC we can find out AB, that is 4. Similarly, by using AC we can find out BC also, or we can use Pythagoras theorem also, but we'll use this one, that is BC is equal to root 3 by 2 times AC, that is root 3 by 2 times 8, that is 4 root 3. Means by using a value of our length of hypotenuse, and if that triangle is 30-60-90 degree, then we can find our side opposite to 30 degree, also we can find side opposite to 60 degree by using property of 30-60-90 degree triangle. Now next property also you have learned during previous year, that is property of 45-45-90 degree triangle. This property of 45, 45, 90 degree triangle. 45, 45, 90 degree triangle. Now again there is one right angle triangle. Since one angle is 90 degree, remaining two angles are 45, 45, means there is right angle isosceles triangle. Suppose triangle ABC in which one angle is 90 degree and remaining two angles are 45 and 45. This angle A is 45, angle C is also 45 degree. Then statement of this theorem tells us that in a right angle triangle, if the remaining two angles or acute angles are 45 degree and 45 degree, then the sides containing right angle or sides opposite to 45 degree are 1 upon root 2 times the hypotenuse. 1 upon root 2 times the hypotenuse. What is the meaning of this one? The triangle is 45, 45, 90 degree triangle. Then the sides containing right angle. Sides containing right angle means right angle is formed because of sides AB and BC, and these are the sides containing right angle, that is AB and BC are 1 upon root 2 times hypotenuse, that is AB is 1 upon root 2 times means into hypotenuse is AC. Also BC is equal to, this is also side containing right angle, BC is equal to 1 upon root 2 times AC. And we can write both statements together as since AB and BC are congruent, since these two are congruent angles and side opposite to congruent angles are congruent by using converse of isosceles triangle theorem or isosceles triangle theorem that we have learned during last year. It is AB is equal to BC is equal to 1 upon root 2 times AC. AB is equal to BC is equal to 1 upon root 2 times AC. This is the meaning of this statement. Means angle sides opposite to 45 degree, that is AB and BC are 1 upon root 2 times AC. This is a better way to keep it in your mind, that is sides opposite to 45 degree. Is both sides AB and BC are 1 upon root 2 times AC. This is about 45, 45, 90 degree triangle theorem. We can solve examples also by using this one. Suppose hypotenuse is given as 10, then side opposite to 45 degree means these two sides will be 1 upon root 2 into 10, that is equal to 5 root 2. This one will be 5 root 2, and this one will be also 5 root 2. Means if hypotenuse is given, then we can find out these two sides also by using this property, and if the angles are 45, 45, 90 degree, then this is about property of 45, 45, 90 degree triangle. Now we'll move towards most important theorem of this lesson, that is similarity and right angle triangle. Similarity and right angle triangle. Theorem. Similarity and right angle triangle. This is important theorem to prove Pythagoras theorem. Right angle triangle. Similarity and right angle triangle. Statement of this theorem is, in a right angle triangle, in a right angle triangle, in the right angled triangle, if the altitude is drawn to the hypotenuse, then the triangles formed are similar to the original triangle and to each other. See once again. In a right angle triangle, if the altitude is drawn to the hypotenuse, then the two triangles formed are similar to the original triangle and to each other. For that we have to draw proper diagram. There is right angle triangle first, obviously. Suppose right angle triangle ABC. Suppose triangle ABC which is right angled at point B. Triangle ABC which is right angled at point B is up to this much. If the altitude is drawn, we have to draw one altitude on hypotenuse. Altitude drawn on hypotenuse. Now here hypotenuse is AC. Altitude means height. We have to draw height on hypotenuse on AC. Suppose BD is an altitude which is drawn on hypotenuse. BD is perpendicular to AC. Then the triangles formed are similar to the original triangle and each other. Now there was simply one triangle first, that is triangle ABC. Now because of this altitude BD, this triangle is divided in two parts, means in two triangles, that is triangle ADB and triangle BDC. Now because of this altitude BD, this triangle is divided in two triangles. Now these two triangles are similar to the original triangle and to each other. Means we have to prove triangle ADB similar to triangle ABC which is original. Triangle BDC similar to triangle original triangle ABC, and these two are similar to each other, that is triangle ADB is similar to triangle BDC. Means we have to prove three statements. First one, this ADB is similar to original, BDC is similar to original, and ADB is similar to BDC. We have to prove these three statements. First step is to draw proper diagram. This is our proper diagram. Next step is to write given. I am writing given here. In triangle ABC, what is given? Measure of angle ABC is equal to 90 degree. Measure of angle ABC is 90 degree and BD or segment BD is perpendicular to hypotenuse AC. Segment BD is perpendicular to segment or side or hypotenuse AC. This much is given. Then what is to prove? That is very important. To prove, number 1, number 2 and number 3. We have to prove the triangles formed are similar to the original triangle and similar to each other. This triangle ADB, first one, triangle ADB is similar to triangle original, that is ABC. Second one, triangle BDC is similar to triangle again original, that is ABC. And third one, to each other, means these two triangles are similar to each other, that is triangle ADB is similar to triangle BDC. Now next part is proof. We'll take this pair first, then we'll take this pair, and then we'll prove this one. First one, in triangle ADB and triangle ABC. In triangle ADB and triangle ABC. Now observe these two triangles. ADB, this triangle, and whole big triangle ABC. What are the common parts? Nothing about sides is given, therefore we can't use here SAS test, we can't use SSS test also. Then therefore remaining test will be simply AA test. We can use AA test here. But how? For that we want two angles or two corresponding angles or pairs of two corresponding angles as congruent. Find out these two pairs, that is in triangle ADB and ABC. We will get one right angle, a pair of right angles here, that is angle ADB. This angle is right angle for this triangle. For triangle ABC, angle B is right angle. Means we can write angle ADB is congruent to angle ABC, region each 90 degree. This angle ADB is congruent to angle ABC, region will be each 90 degree. Now we want one more pair to prove these two triangles similar of angles. Observe this angle. It is angle A. Is it common angle for these two triangles? See, angle A is angle of this triangle ADB, which is shaded, and angle A is angle of this bigger triangle also, that is triangle ABC. But the names are different. For this smaller triangle, name of this angle is angle DAB. A should be in between or in middle. DAB is congruent to angle DAB is congruent to angle BAC. Angle is same but the names are different. Angle BAC, region is common angle. Hence triangle ADB is similar to triangle ABC by AA test. Suppose this is statement number 1. So statement number 1 means we have proved this one. Now we'll move towards second part, that is in triangle BDC and triangle ABC. In triangle BDC and triangle ABC. Now observe these two triangles. BDC, this one, and ABC again bigger triangle, bigger triangle, that is original triangle. Again, what are congruent parts in these two triangles? That is angle BDC, which is right angle, and angle ABC is right angle. Therefore angle BDC is congruent to angle ABC, region each 90 degree. We'll get one more pair also here. Now observe this angle, that is angle C, which is the angle of this triangle and angle of this bigger triangle also, but the names are different. Sorry. For the smaller triangle, name of this angle will be DCB. Angle DCB is congruent to angle. For bigger triangle, it is BCA. C should be in between, in middle. BCA, region is common angle. Hence, triangle BDC is similar to triangle ABC again by AA test. So this is statement number 2. Means we have proved this also. BDC is similar to triangle ABC. Means we have proved statement number 1. We have proved statement number 2 also, but we will not prove statement number 3 in this way. We'll prove straightforward that is triangle ADB is similar to triangle BDC. For that, observe statement number 1 and 2. ADB is similar to ABC and ABC is similar to BDC. Therefore, can I write directly that is ADB is similar to BDC? For that, we know transitivity property. I'll just revise this transitivity property. This property tells us that I'm telling about segments. Suppose AB is congruent to BC and BC is congruent to AB is congruent to CD, CD is congruent to PQ, then AB is congruent to CD and CD is congruent to PQ, then AB will be congruent to PQ. AB is congruent to PQ. We see first side is congruent to second, second side is congruent to third, then first and third are congruent with each other. This is about congruent segments. This property is also about congruent angles and congruent triangles and for similar triangles also. Means we can use this transitivity property. This property also we have learned during previous year. That is, the first is congruent to second, second is congruent to third, then first is congruent to third. Now we will use this property for similarity. Now first triangle is similar to second, ABC is second, ABC again. Second triangle is similar to third, then first is similar to third. Hence by using 1, 2 and by transitivity property, is from statement number 1, 2 and transitivity property, we can write directly that is triangle ADB is similar to triangle BDC. Triangle ADB is similar to triangle BDC. Yes, we have proved this also straightforward. Means all these three triangles are similar with each other. I am writing this statement also here. That is triangle ADB is similar to triangle BDC is similar to triangle ABC. Means all these three triangles are similar with each other. ADB is similar to BDC is similar to ABC. Hence proved. See once again. There is one right angle triangle which is right angled at point B, and there is one altitude drawn on hypotenuse, that is BD. Altitude is nothing but height or perpendicular. BD is perpendicular to AC. This is given, and we have to prove because of this altitude the two triangles formed are similar to the original triangle and similar with each other. Now we will take first pair, that is triangle ADB and triangle ABC. In triangle ADB and triangle ABC, angle ADB is congruent to angle ABC. Reason each 90 degree. Angle A is common angle but the names are different. That is angle DAB is congruent to angle BAC. Reason is common angle. Hence triangle ADB is similar to triangle ABC by A test statement number 1. Now by taking second pair, that is triangle BDC and triangle ABC. In triangle BDC and triangle ABC, again angle BDC is congruent to angle ABC. Reason is each 90 degree. Angle DCB and angle BCA, which is common angle. Angle C is common to both triangles but the names are different. Reason common angle. Hence triangle BDC and triangle ABC are congruent, similar by A test statement number 2. Hence from 1, 2 and by transitivity property, that is first triangle is similar to second, similar to third. Hence triangle ADB, triangle BDC. Hence both all these three triangles are similar with each other. That is triangle ADB is similar to triangle BDC is similar to triangle ABC. A very important theorem, that is similarity and right angle triangle. It is in your textbook also. If you want screenshot, then take. And we'll move towards next part. This theorem of geometric mean, which is based on this theorem. Therefore I'll take it today only. This theorem of geometric mean. Next theorem, that is theorem of geometric mean. Statement of this theorem is, in a right angle triangle, the perpendicular segment drawn on hypotenuse is geometric mean of the segments into which it is divided. Is the geometric mean of the segments into which the hypotenuse is divided. It is means hypotenuse is divided. In a right angle triangle, the perpendicular segment drawn on the hypotenuse is the geometric mean of the segments into which the hypotenuse is divided. Though this statement is bigger, the meaning of this statement is very easy. Suppose I am drawing this diagram according to your textbook. Suppose triangle PQR. This is your triangle PQR, which is right angle triangle and right angled at point Q. This is right angle triangle PQR. Now, in a right angle triangle, the perpendicular segment drawn on the hypotenuse. Now, hypotenuse is PR. PR is hypotenuse, and we have to draw perpendicular on hypotenuse from its opposite vertex. From its opposite vertex, when that point is there. From its opposite vertex. That is, suppose point Q, and this perpendicular segment is QS. Perpendicular segment drawn from its opposite vertex on hypotenuse is the geometric mean of the segments into which that hypotenuse is divided. Now, what is given here? It is in triangle PQR. In triangle PQR, major angle PQR is equal to 90 degree. This it is right angle triangle, and segment QS is perpendicular to segment PR. Segment QS is perpendicular to segment PR. This is given, and what is to prove? What is to prove? The perpendicular segment is the geometric mean of the parts or of the segments into which that hypotenuse is divided. Means QS is the geometric mean of the parts or the segments into which hypotenuse is divided. Now, because of this perpendicular segment, this hypotenuse PR is divided in two parts, that is PS and SR. Means QS is geometric mean of PS and SR, and that is nothing but I can write this as PS is geometric mean, means PS square is equal, PS not QS square. QS is geometric mean of PS into SR. I'll tell you meaning of geometric mean first. Suppose A, B and C are three numbers, and if A upon B is equal to B upon C, if A upon B is equal to B upon C, then B is geometric mean of A and C. If this condition is satisfied, then B is said to be, or that middle number is said to be geometric mean of the first and third numbers. And we can write by using cross multiplication, B into B means B square is equal to product of remaining two numbers, that is A into C. B square is equal to A into C, means geometric square of the geometric mean will be equal to product of the remaining two numbers. Square of the geometric mean will be equal to product of remaining two numbers. Now we have to prove this theorem. Next step is proof. Proof is very simple. We have proved in previous theorem, that is because of the same diagram is there is one right angle triangle and altitude is drawn on the hypotenuse, and because of this altitude this triangle is divided in two parts or two triangles, and these two triangles are similar to original triangle and similar to each other. Means triangle QSR is similar to triangle RQP, PSQ is similar to triangle RQP, and these two are similar to each other. Now we'll take this pair by using previously proved theorem, that is triangle QSR is similar to triangle PSQ. By using that theorem I can write it directly, that is triangle QSR is similar to triangle PSQ, similar to triangle PSQ, by using that previously proved theorem that we proved just now. That is triangle QSR, this triangle is similar to triangle PSQ. These two triangles are similar to each other. Now since these two triangles are similar and if the names are perfect, check the names. QSR means angle S, which is right angle is in between, is similar to PSQ. S is also in between, but I'll start P first. QSR, okay. Means common angle is last, at last, QSR and PSQ. Now since these two triangles are similar, therefore their corresponding sides are in proportion. That is QS upon PS is equal to SR upon SQ is equal to QR upon PQ. Reason will be CSST, that is corresponding sides of similar triangles. Now out of these three ratios we will take only two ratios containing these four, means QS is twice, that is first and second, means I will not take this one. I am writing these two first ratios again. QS upon PS is equal to SR upon SQ, means again QS. SQ and QS both are same. Then by cross multiplication we will get QS into QS, that is QS square is equal to PS into SR. That was our target. QS square is equal to PS into SR. Proof is very simple. See once again meaning of this geometric mean property. In a right angle triangle, the perpendicular segment drawn on the hypotenuse from the opposite vertex is geometric mean of the segments into which the hypotenuse is divided. Now there is one right angle triangle PQR which is right angled at point Q, and there is one perpendicular on hypotenuse from its opposite vertex, that is QS is perpendicular to PR, and we have to prove QS is geometric mean of PS and SR, means of the parts of the hypotenuse at which at which hypotenuse is divided. Means QS is geometric mean of PS into PS and SR, means we have to prove QS square is equal to PS into SR. And to prove this we will use previously proved theorem. Because of this altitude, this triangle is divided into two triangles, and these two triangles are similar to original triangle and similar to each other. Now we will use this last part, that is these two triangles are similar to each other, that is triangle QSR is similar to triangle PSQ. Now since these two triangles are similar, therefore their corresponding sides are in proportion, taking pairs of corresponding sides or ratios of corresponding sides, that is corresponding sides of similar triangles. Out of these three ratios, we will choose only two ratios containing these four sides, that is QS twice. QS upon PS is equal to SR upon SQ, and SQ is nothing but QS, that is QS into QS, QS square is equal to PS into SR, means QS is geometric mean of PS and SR. This is about geometric mean property. Tomorrow we will learn about proof of Pythagoras theorem. We will stop here. Thank you.